Very good morning, students. Today shall start matrices. So in this chapter, first we shall discuss about the matrix, order of a matrix, types of matrices. Okay, the definition of a matrix, order of a matrix. So then row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, upper triangular matrix, and lower triangular matrix. So first we shall define what is a matrix. So matrix is an rectangular arrangement of numbers, nothing but an arrangement of numbers in rows and columns. An arrangement of numbers in rows and columns. That is, for example, arrangement of numbers, particularly numbers are real or it may be complex. Arrangement of numbers in rows and columns, that is 3, 5, 7, 8, 10, minus 3. First row elements, and this is the second row elements. And generally matrices are represented by capital alphabets, that is A, arrangement of numbers in rows and columns enclosed within the brackets anta helirthivi. Brackets means we can use a square bracket, or we can use an open bracket, or we can use this one, representation of matrices. So a matrix containing two rows and first column, second column, third column. So first row elements are 3, 5, 7, second row elements are 8, 10, minus 3. So arrangement of the numbers in rows and the column. First column elements 3 and 8, second column elements 5 and 10, and third column elements are 7 and minus 3. This represents first column, column 1, column 2, column 3, and this one is first row and this one is the second row. Nothing but arrangement of the numbers in rows and column and the entries. ಇಲ್ಲೇ ನಾವು ನಂಬರ್ಸ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಆ ನಂಬರ್ಸ್ ಏನಾಗಿರಬೇಕು, ರಿಯಲ್ ಆರ್ ಇಟ್ ಮೇ ಬಿ ಎ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್. And generally matrices are represented by using capital alphabets like capital A, capital B, capital C, like this. And the elements in the matrices are generally represented by small letters A, B, C, like this. And the arrangement of numbers in rows and column enclosed within the bracket anta helತೀವಿ. It means that we can use a square bracket or a small bracket, or we can represent the matrices by this one also. That is, again, it means matrix, an arrangement of numbers in rows and columns, and the numbers, arrangement of the numbers, the entries in the matrices are either real numbers or the complex numbers. And then after the definition of the matrix, we shall discuss about the order of a matrix. Order of a matrix. So let us represent the matrix in general. That is first row, first element A11, A12, A13, and this is A1n. And then A21, A22, A23, and this is A2n. So on, AM1, AM2, AM3, and this is AMN. Okay, this is the matrix A. See here, it indicates first row elements. A11 means this is the first row, first element. A12 means first row, second element. A13 means first row, third element. So on, and this is the first row, nth element. So this represents R1, row 1, and this is row 2, and this is row 3, and this one is column 1, column 2, column 3, and this is the nth column. So ಇಲ್ಲಿ ತಗೊಂಡಿರೋದು mth row RM. So A11 again, A11 means first row, first element. A12 means first row, second element. A13 means first row, third element, and this is the first row, nth element. It means first suffix indicates row, second suffix indicates the column. So again, A11 means first row, first element, first row, second element, first row, third element, first row, nth element. Similarly, so A21 means it is an element of second row, first column. A22 means second row, second column. A23 means it's an element of second row, third column, and this one is the second row, nth column. So in general, AM1 means mth row, first element, mth row, second element, mth row, third element, and this is the mth row, nth element. It means that this matrix has m number of rows and n number of columns denoted by m by n. M by n. M indicates the number of rows and n indicates the number of columns. So this is prescribed as, simply represented as Aij, that is mn. So Aij means I indicates the row and j indicates the column. So all the elements of this matrix can be prescribed in one form, that is A is equal to Aij. Again, I indicates row and j indicates column, and m by n indicates the order of the matrix. It means that the matrix A has m number of rows and n number of columns. So allige finally what we said, order of a matrix means order of a matrix represents the number of rows and the number of columns where the matrix has. So that represents m number of rows and n number of columns. Okay. After this, we shall move to the types of matrices. So before that, we shall discuss about the rectangular matrix. Rectangular matrix. If the number of rows of the matrix is not equal to number of columns, number of rows of the matrix is not equal to number of columns, then it is called as the rectangular matrix. That is, I already said that I represents the row and j represents the column. That is, the matrix A is equal to Aij, that is m by n. A matrix of order m by n, I indicates row, j indicates column. If I is not equal to j, then it is a rectangular matrix. So for example, let us take the matrix A is equal to -2, -3, -5, -1, 6, and this is 7. So the matrix A has first row, second row. It means it has 2 rows. Order of the matrix. So first thing is 2 because it contains 2 rows, and first column, second column, third column. That is, order is 2 by 3. So that is the matrix A has 2 rows, 3 columns. First column, second column, third column. So order of the matrix is 2 by 3. Here number of rows is 2. Number of columns is 3. So clearly 2 is not equal to 3. So it is a rectangular matrix. So a matrix is said to be a rectangular matrix if the number of rows is not equal to the number of columns. That is a rectangular matrix. So in that there are 2 cases. Again, row matrix and the column matrix. Row matrix. If the matrix has only one row, then it is called as row matrix. So let us take matrix A is equal to A1 1, A1 2, A1 3, and this is A1 n. A matrix is said to be a row matrix if it has only one row. See here, first row first element, first row second element, first row third element, first row nth element, but it has n number of columns. That is first column, second column, third column, and this is the nth column. A matrix is said to be a row matrix if it has only one row. So finally the order of the row matrix is one row, n number of columns. The matrix is said to be row matrix if it has only one row, but it has n number of columns. That is first row, only one row, but the number of columns, first column, second column, third column, and this is the nth column. Only one row, but the number of columns are n. That is row matrix. So particularly we can take the matrix A is equal to -1, -5, -10, -20. It has only one row, but the number of columns, first column, second column, third column, fourth column. So its order is one row, but number of columns are 4. That is a row matrix. So after that, column matrix. A matrix is said to be a column matrix. It has only one column. Obviously it has m number of rows. That is, let us take the matrix A is equal to A11, A21, and this is A3, AM, and this is 1. So first column, second column, and this is the mth column, mth row. First row, second row, third row, fourth row, and in general this is the mth row, but the number of column is only 1. So a column matrix, a matrix is said to be a column matrix if it has only one column, but it has m number of rows, first row, second row, third row, and this is the mth row. So in particular, matrix A is equal to 5, 10, 15, first row, second row, third row, but the number of columns is only 1. So order is 3 rows, but the number of column is 1. So order of the column matrix can be taken as m by 1, and order of the row matrix can be taken as 1 by n. So it has, row matrix means it has only one row. Only one row. First number represents row, second number represents the column. It has one row, but the number of columns n. So in case of column matrix, so it has only one column, but the number of rows are m. So in general, order of the column matrix can be taken as m by 1. So this is the particular case. See here, only one column, but it has 3 rows. First row, second row, third row. So its order is 3 by 1. So rectangular matrix, a matrix is said to be a rectangular matrix if the number of rows is not equal to the number of columns, or a matrix is said to be a rectangular matrix if the number of rows is not equal to number of columns. In that there are 2 cases, row matrix and a column matrix. A row matrix, a matrix is said to be a row matrix if it has only one row and its order can be taken as 1 by n. A matrix is said to be a column matrix if it has only one column and its order can be taken as m by 1. So after this, we shall discuss about the square matrix. A matrix is said to be a square matrix if the number of rows is equal to the number of columns. So in case of rectangular matrix, number of rows not equal to number of columns, but in case of square matrix, number of rows is equal to the number of columns. A matrix is said to be a square matrix if the number of rows is equal to the number of columns. That is, a matrix A is equal to Aij is said to be a square matrix if I is equal to j. It means, I already said that I represents row, j represents columns. I is equal to j means number of rows equal to the number of columns. For example, let us take the matrix A is equal to 1, 2, 3, 5, 7, 11 and this one 13, 17 and this is 19. Number of rows, first row, second row, third row. It has 3 rows. Number of columns, first column, second column, third column. So it has 3 columns. See here, m is equal to n. That is, number of rows is equal to the number of columns is called as a square matrix. Or you can take the matrix B is equal to 1, 8, 27 and this is 36. Number of rows, first row, second row. It has 2 rows and 2 columns. First column, second column. That is 2 by 2. Number of rows is equal to number of columns. A matrix is said to be a square matrix if number of rows is equal to the number of columns. So in square matrix, after that shall define diagonal matrix. Diagonal matrix. Before defining diagonal matrix, we shall discuss about the diagonal elements. Diagonal elements means in a square matrix, the elements from left top corner to the right bottom corner. Diagonal matrix now define ಮಾಡಬೇಕು ಅಂದ್ರೆ ನಮಗೆ diagonal elements ಗೊತ್ತಿರಬೇಕು. Okay, so in a square matrix, the elements from left top corner to the right bottom corner are called as the diagonal elements. So in this case, the diagonal elements are 1, 7, 19, and in this case the diagonal elements are 1 and 36. It means that it's a first row, first element, and this is the second row, second element, and this is the third row, third element. These are the diagonal elements. So in a matrix A, the diagonal elements are 1, 7 and 19, and here in the matrix B, the diagonal elements are 1 and 36. So now we shall define diagonal matrix. So a matrix, a square matrix, it means that diagonal matrix ನಾನು ಡಿಫೈನ್ ಮಾಡಬೇಕು ಅಂದರೆ ಆ diagonal matrix ಅನ್ನೋದು ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸೇ ಆಗಿರಬೇಕು. ಓಕೆ, a square matrix is said to be a diagonal matrix. A square matrix is said to be a diagonal matrix if all the non-diagonal elements are zeros. So here the diagonal elements are 1, 7 and 19. Non-diagonal elements are 2, 3, 11, 5, 13 and 17. ಈ non-diagonal elements ಏನಾಗಬೇಕು? zeros ಆಗಬೇಕು. That is, let us take the matrix A is equals to, it contains only the diagonal elements. As the name itself indicates, the matrix must contains only the diagonal elements. Non-diagonal elements must be 0. So let us take 1, 0, 0, 0, 7, 0, and this is 0, 0, and this is 19. Again order, number of rows 3, number of columns 3. So a square matrix is said to be a diagonal matrix if all the non-diagonal elements are zeros. It means it contains only diagonal elements. Diagonal elements means in a square matrix, the elements from left top corner to the right bottom corner are called as the diagonal elements. Here, in this case, it contains only diagonal elements 1, 7, 19. All the non-diagonal elements are zeros. So let us take another example. A matrix of order 2 by 2. This is 5 and this is 25. Non-diagonal elements are 0. Order 2 by 2. So here, again this matrix contains only diagonal elements. Non-diagonal elements are 0. It means ನೀವು diagonal matrix na define ಮಾಡಬೇಕು ಅಂದ್ರೆ it should be a square matrix. A square matrix is said to be a diagonal matrix if all the non-diagonal elements are zeros. It means that it contains only diagonal elements. So after that, next move to the scalar matrix. Again, scalar matrix is a square matrix. Scalar matrix is a diagonal matrix. So a matrix is said to be a scalar matrix. Scalar matrix can be defined in two ways. First case, a square matrix is said to be a scalar matrix. A square matrix is said to be a scalar matrix if all the diagonal elements are same. A scalar matrix is said to be a square matrix is said to be a scalar matrix if all the diagonal elements are same. Let us take the example. That is 1. So let us take this as 5, 0, 0, 0, 5, 0, 0, 0, 5. Obviously, it has 3 rows and 3 columns. It is a square matrix. A square matrix is said to be a scalar matrix if all the diagonal elements are same. See here, diagonal elements A11, 5, A22, 5, A33 is also 5. Diagonal elements are same. This is one definition. Another definition is a scalar matrix is a diagonal matrix. See here, diagonal matrix ಮತ್ತು scalar matrix ಎರಡು ಕಂಪೇರ್ ಮಾಡಿಕೊಂಡ್ರೆ ನಾನ್ diagonal elements zeros ಇದೆ. Non-diagonal elements are zeros. See here, non-diagonal elements are different. What is the difference between the diagonal matrix and the scalar matrix? So scalar matrix is a diagonal matrix. Scalar matrix is a diagonal matrix means a diagonal matrix, a square matrix is said to be a diagonal matrix if all the non-diagonal elements are same. Here also non-diagonal elements are same. What is the difference? Here the diagonal elements are different or it may be same, but in case of scalar matrix, all the diagonal elements must be same. Now diagonal matrix na define ಮಾಡಬೇಕಾದ್ರೆ non-diagonal elements zeros ಆಗಬೇಕು ಅಂತ ಹೇಳ್ತೀವಿ. ಕಂಪಲ್ಸರಿ non-diagonal elements zeros ಆಗಬೇಕು. ಈ diagonal elements ಏನಾಗಿರಬೇಕು, ಪ್ರೆಸೆಂಟ್ ಆಗಿರಬೇಕು. diagonal elements ಪ್ರೆಸೆಂಟ್ ಇರಬೇಕು ಅಂದ್ರೆ ಈ diagonal elements ಸೇಮ್ ಇರಬಹುದು ಇಲ್ಲ ಡಿಫರೆಂಟ್ ಇರಬಹುದು. But in case of scalar matrix, diagonal elements must be same. ಅಲ್ಲಿಗೆ diagonal ನಾವು ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ scalar matrix. A scalar matrix is a diagonal matrix. Scalar matrix is a diagonal matrix. All the diagonal elements must be same. So in two cases, a scalar matrix is a diagonal matrix, but all the diagonal elements must be same. So scalar means ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಸೇಮ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಇಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತಲೂ ಹೇಳ್ತೀವಿ. ಅಂದರೆ ಅರ್ಥ ಅಲ್ಲಿ ಇಲ್ಲಿನೇನು ನಾವು ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ತೊಗೊಳ್ತಾ ಇದ್ದೀವಿ, ಈ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾಗಿರಬೇಕು, ಸೇಮ್ ಇರಬೇಕು ಅಂತ. ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ಡಿಫೈನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನು ಹೇಳ್ತೀವಿ, ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಸೆಟ್ ಟು ಬಿ ಎ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಫ್ ಆಲ್ ದ ನಾನ್ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಝೀರೋಸ್. ಓಕೆ, ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಈ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಸೇಮ್ ಇರ್ಬೋದು ಅಥವಾ ಡಿಫ್ರೆಂಟ್ ಇರ್ಬೋದು. ಸೊ ದಿಸ್ ಇಸ್ ಎ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. Diagonal elements are different, here the diagonal elements are same. But scalar matrix na define ಮಾಡಬೇಕಾದ್ರೆ ಈ diagonal elements compulsory same ಇರಬೇಕು. That is, a scalar matrix is a diagonal matrix in which all the diagonal elements are same. This is the scalar matrix. And after that, identity matrix, or it can also be called as unit matrix. Identity bar unit matrix. So identity matrix or unit matrix. Identity matrix is a scalar matrix. Identity matrix is a scalar matrix. in which all the diagonal elements are equal to 1. So unit, the name itself indicates the matrix, and the identity matrix is represented by capital I, and this is 1 0 0 0 1 0 0 0 1. Again it has 3 rows and 3 columns. Its order is 3 by 3. Again identity matrix of order 2 by 2, 1 0 0 1. So what is the difference? See here, identity matrix is a scalar matrix in which all the diagonal elements are equal to 1. See here, diagonal matrix, a square matrix is said to be a diagonal matrix if all the non-diagonal elements are zeros. It means diagonal elements ಮಾತ್ರ ಪ್ರೆಸೆಂಟ್ ಆಗಿರಬೇಕು. ಆ diagonal elements ಸೇಮ್ ಇರಬಹುದು ಇಲ್ಲ ಅಂದರೆ ಡಿಫರೆಂಟ್ ಇರಬಹುದು. ಇದು ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಮಾತ್ರ ಪ್ರೆಸೆಂಟ್ ಆಗಿದೆ. ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೂ ಕೂಡ ಅದೇ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳ್ತೀವಿ. ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಎ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಈಸ್ ಸೆಟ್ ಟು ಬಿ ಎ ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಫ್ ಆಲ್ ದ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಸೇಮ್. ಈ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾಗಿರಬೇಕು? ಸೇಮ್ ಇರಬೇಕು. ಹಾಗಿದ್ರೆ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೂ ಹಾಗೆ ಹೇಳ್ತೀವಿ. ಬಟ್ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಈ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾಗಿರಬೇಕು? ಈಕ್ವಲ್ ಟು 1 ಆಗಿರಬೇಕು. So identity matrix or unit matrix is a scalar matrix in which all the diagonal elements are equal to 1 only. So this is identity matrix, and this is the scalar matrix, and this is the diagonal matrix. So identity matrix is a square matrix. Identity matrix is a square matrix in which all the non-diagonal elements are zeros and diagonal elements are equal to 1. Or identity matrix is a scalar matrix. Identity matrix is a scalar matrix in which all the diagonal elements are equal to 1. ಅಂದರೆ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ನೀವು ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಸ್ಕ್ವಯರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ನೀವೇನಾದರೂ ತೊಗೊಂಡ್ರೆ, ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ನೀವು ಸ್ಕ್ವಯರ್ ಮ್ಯಾಟ್ರಿಕ್ಸಲ್ಲಿ ಡಿಫೈನ್ ಮಾಡ್ತಾ ಹೋದರೆ, ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಎ ಸ್ಕ್ವಯರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇನ್ ವಿಚ್ ಆಲ್ ದ ನಾನ್ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಝೀರೋಸ್ ಆ್ಯಂಡ್ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1 ಅಂತ ಹೇಳಬೇಕು. ನೀವು ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ಇನ್ ಕೇಸ್ ಆಫ್ ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸಲ್ಲಿ ಹೇಳೋದಾದರೆ, ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಎ ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇನ್ ವಿಚ್ ಆಲ್ ದ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1. ಅಂದರೆ 2 ವೇಸಲ್ಲಿ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು ಅಂತ ಅರ್ಥ. ಓಕೆ, ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಈಸ್ ಎ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಈಸ್ ಎ ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ನೀವು ತೊಗೊಂಡ್ರೆ ಅದು ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಕೂಡ ಆಗಿರುತ್ತೆ ಮತ್ತು ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಕೂಡ ಆಗಿರುತ್ತೆ. ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಈಸ್ ಎ scalar matrix as well as diagonal matrix. See here, identity matrix is a scalar matrix. Scalar matrix ಯಾಕಾಗುತ್ತೆ? ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ನಾವು ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಈ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಸೇಮ್ ಇರಬೇಕು ಅಂತ ಹೇಳ್ತೀವಿ. See here, diagonal elements are same. ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ನೀವು ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸಲ್ಲಿ ಹೇಳಬೇಕು ಅಂದರೆ, ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸಲ್ಲಿ ಏನು ಹೇಳ್ತೀವಿ? ನಾನ್ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಝೀರೋಸ್ ಆಗಿರಬೇಕು ಅಂತ ಹೇಳ್ತೀವಿ, ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಆಗಿರಬೇಕು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀವಿ. See here, ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಆಗಿದೆ ಮತ್ತು ನಾನ್ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಝೀರೋಸ್ ಆಗಿದೆ. ಸೊ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಎ ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಎ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆರ್ ಯೂನಿಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಈಸ್ ಎ ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಸ್ ವೆಲ್ ಆಸ್ diagonal matrix. Scalar matrix is a diagonal matrix. Scalar matrix must be a diagonal matrix, but identity matrix is both scalar matrix as well as diagonal matrix. Okay. After that, upper triangular matrix and the lower triangular matrix. Upper triangular matrix. Again, upper triangular matrix is a square matrix. Upper triangular matrix is a square matrix, obviously. So matrix A is equal to elements below the principal diagonal elements zeros irbeku, -5, -10. Upper triangular matrix, this is 6, 8 and this is 14, 0, 0, 0. Upper triangular matrix andre elements below the principal diagonal elements are zeros. See here, ಇದು ಮಾತ್ರ ಪ್ರೆಸೆಂಟ್ ಇರಬೇಕು. Upper triangular matrix elements, these are the elements below the principal diagonal. Upper triangular matrix is a square matrix in which the elements below the principal diagonal elements are zeros. See here, minus 1, again it is a order of, its order is 3 by 3. The elements in the first row, minus 1, 6, 8, minus 5, 14, and then minus 10. Okay, 0, minus 5, 14, 0, 0, minus 10. Observe ಮಾಡಿ, elements below the principal diagonal elements are zeros. ಅಂದರೆ ಅಪ್ಪರ್ ಟ್ರಯಾಂಗ್ಯುಲರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಮತ್ತು ಅದರ ಮೇಲೆ ಇರ್ತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಆಗಿರುತ್ತೆ. ಎಲಿಮೆಂಟ್ಸ್ ಬಿಲೋ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಕಂಪಲ್ಸರಿ 0 ಆಗಿರಲೇಬೇಕು. ಎಲಿಮೆಂಟ್ಸ್ ಬಿಲೋ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಮಸ್ಟ್ ಬಿ 0. ದಟ್ ಈಸ್ ಅಪ್ಪರ್ ಟ್ರಯಾಂಗ್ಯುಲರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಲೋಯರ್ ಟ್ರಯಾಂಗ್ಯುಲರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. Again, lower triangular matrix is again a square matrix in which the elements above the principal diagonal elements are zeros, and this is 5, 10, and this is 6, 0, 0, 0, and this is minus 2, minus 4, minus 6. See here, these elements are zeros. Its order is again 3 by 3. Lower triangular matrix is a square matrix. Lower triangular matrix is again a square matrix in which the elements above the principal diagonal elements above the principal diagonal elements are zeros. Observe ಮಾಡಿ. That is a12 is 0, a13 is 0, a23 is also 0. ಈ elements ಮಾತ್ರ ಪ್ರೆಸೆಂಟ್ ಆಗಿರುತ್ತೆ. This is upper triangular matrix and this is the upper triangular matrix and this is the lower triangular matrix. So upper triangular matrix is a square matrix. Upper triangular matrix is a square matrix in which the elements below the principal diagonal elements are zeros, compulsory zeros. Lower triangular matrix is a square matrix in which the elements above the principal diagonal elements are zeros. So this is upper triangular matrix and this is the lower triangular matrix. So this is all about the matrix, order of a matrix, row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, upper triangular matrix and lower triangular matrix. These are all the types of matrices. So in your examination you will get compulsory 5 marks 2 questions in matrices. 5 marks 2 questions. And also you will get one compulsory question in your seat and in general. One compulsory question. Okay.